welcome to DataBelt. My name's Matt Smith and I'm Head of Pre-Sales at AIM. In this video, I'm going to cover DataBelt's application in the police and law enforcement context, covering both investigative and corporate data use cases. However, DataBelt is a complete data governance solution, supporting diverse use cases across all industries. So please take a look at the other demonstrations on our YouTube channel to find out more. There are many data challenges facing modern policing and law enforcement. Crime is ever prevalent in society, with criminals becoming increasingly sophisticated in their methods, particularly when it comes to data-related crime. Globalization presents additional challenges, with crime crossing county, national, and international borders. Police forces and law enforcement agencies collaborate but are often under-resourced. Agencies also need to deal with huge volumes of data in many locations and formats, while also dealing with the increased demands of bodies such as HMICFRS, NPCC, and the Home Office in the form of regulations, guidance, and reporting. Additionally, as an employer, police forces need to meet the normal legal and regulatory demands of data management, compliance, data protection, and security. Police force data is extensive, high volume, and complex, divided into two main categories: investigative data and corporate data. Investigative data may take the form of CCTV footage of a crime, whereas corporate data, as an example, may be an internal HR report relating to a colleague. A typical police force data model is shown in the diagram here. Data forensics is now a vital tool for police forces in the fight against crime, as data and its analysis provide incisive intelligence on criminal and fraudulent activity. But data forensics cannot rely on manual methods for the speed, accuracy, and depth of interrogation needed in policing. Modern AI-powered software is the solution. In response to these challenges, AIM has developed an enterprise-level, expert data governance platform to address each and every one of these law enforcement issues and converge them in support of a data value chain for a police force's data governance framework. AIM and DataBelt boast an impressive pedigree in the data governance space. Seen as a forerunner in the practice, and with high-profile customers in law enforcement and the private sector, DataBelt has been recognized by the analysts Forrester as a leader in data indexing, classification, and governance in two Now Tech reports in 2020 and 2021. Additionally, AIM and DataBelt will be contributing in 2021 to Forrester's new Data Governance Solutions wave. DataBelt is able to interrogate any data from any data source. Data types range all the way from audio recordings, for example recorded telephone conversations, through to emails, photographs, scanned documents, and data shares. As a result, DataBelt can locate anything, any person, any sound, any image, any language character. As audio files are automatically transcribed during its indexing process, DataBelt can find instances of keywords or phrases mentioned in phone calls. With its ability to create AI models, a person of interest can be identified in CCTV footage showing the timestamps at which the person appears. Using the same AI model capability, scanned documents or photographs of documents are analysed and compared against models of other documents such as invoices, P45s, and contracts. Some of DataBelt's functional and non-functional features are listed here. From the functional side, DataBelt consists of a number of microservices grouped by functional collections, including data forensics, fraud detection, and e-discovery, data hygiene and compliance, data classification and GDPR, and data blueprint. It uses AI and machine learning, RPA or robotic process automation, Elasticsearch, and natural language processing technologies to deliver its capabilities. On the non-functional side, DataBelt is available on-premise or cloud, can be containerized and blockchain deployable, is fully encrypted, and many features follow a low-code or no-code approach to allow non-developers to configure and administer its powerful features. The greatest levels of fraud and corruption in the modern world are via electronic means, which proves that electronic data is the chief source of both prevention and investigative detection available to counter-fraud agencies. DataBelt provides an all-in-one solution to support counter-fraud activities, and shortly I'm going to introduce the use cases that will form the basis of the remainder of this presentation. I'm now going to demonstrate DataBelt's capability in both the investigative and corporate data side of policing and law enforcement. Starting off with two example investigations, I'm going to show how DataBelt supports intelligence gathering in a prison setting relating to a burner phone confiscation. I'll then move on to how DataBelt's CCTV analysis and AI model creation capability supports a fictional county lines shooting investigation. Moving on to the corporate data use cases, I'll cover how DataBelt supports an end-to-end custody suite photo weeding and freedom of information request process before moving on to a data subject access request and disclosure for a legal HR case. Before we log into DataBelt and cover off our first use case, it's important to understand what underlies DataBelt's capability. One of the best ways we find in demonstrating this is with this visualization. What underpins DataBelt's capability is its ability to index data. And what it's doing is using a number of different workers, which are these small people icons that you can see whizzing around the screen. They are going off to certain file locations and iteratively going through folders and the like, finding different files, and then going through subfolders and doing the same thing all the way down until it's indexed everything that we've pointed the workers at. And during this process, it of course does the simple things, so it's indexing things like the names of the files, the size of the files, the types of the files. You can see we have 63 PDFs here, 147 zip files, 154 JPEGs, just as an example. What it's also doing is some advanced indexing, and what that is things like optical character recognition. So any characters that are found within an image are actually being drawn out of that image and saved and indexed. So if you have a custody suite photograph of a person with their CR number, that can be pulled out and saved automatically and searched on, and that's what we're going to be doing today. It also does audio transcription, so where we're going to be looking at a prison telephone recording, it's finding that recording and it's automatically transcribing what's going on in that conversation so that we can search on the text that's in there. Any AI models that we've created, and we'll come on to this later, are also being used and searched against that index. Our first use case relates to prison telephone call analysis and subsequent burner phone confiscation and intelligence gathering. The background is that the Prison Service and Ministry of Justice are concerned about the increase in illegal burner phones used in prisons. The prison authorities want assistance in targeting where they should look. The purpose of the investigation is to identify mentions of the word burner in recorded prison telephone calls, and to identify suspects and to analyse the confiscated burner phones to ascertain whether the suspect is continuing to carry out criminal activities on the outside while being incarcerated. The use case steps are as follows. The prison service provides prison audio phone recordings to the police. The police create an investigation case in DataBelt. They then go on to index and automatically transcribe the audio files into text, and then carry out a data deep search against the transcribed audio files for mentions of the slang keyword burner. Suspicious recording is located. This information is then passed on to the relevant prison officers, who then carry out a search of the cell of the prisoner and locate a burner phone. The contents of the phone are exported and then indexed within DataBelt, and useful information is found, for example a passport. So I've logged into DataBelt, and we're going to cover off our first use case now, which is the prison phone call analysis and burner phone confiscation and intelligence. And I've started off on the My View page here just because I wanted to tell you a little bit about how DataBelt works in terms of cases, and we'll come back to this screen quite a lot throughout all of the other use cases as well. What you see here is a number of microservices collections. So on the left hand side in purple we have our data forensics, fraud detection and e-discovery section. And then we have 4 tiles under that. These are our microservices that do different things within DataBelt. And what we do when we create a case is we select a specific microservice. In this case it would be a data deep search, and then click proceed at the bottom right. This creates a case that will then follow us throughout this journey. And the reason that we have cases for the actions that we carry out is that DataBelt is incredibly powerful, and we need to understand the audit trail of what people are searching, what people are doing on the platform. So cases are required to do things like searching and querying the indexes and virtualized data lakes that we create as part of using DataBelt. So our first step here is of course to actually get those phone recordings from the prison service, and in our case here they've been saved onto a local drive. And we need to go ahead now and index that data so that we can search on it. We've gone into our CMDB here. This stands for Configuration Management Database, and it's you can see it as being a map of all of the servers and file stores, etc., that make up our data estate and our infrastructure estate. And what we have here is data store 3 is the example data store where we have saved our prison phone recordings. And what we need to do now is create an index. You'll see there are a number of indexes already on that data store. And if I just click on create new, we have our create an index module. Now it's very simple, there are just a few fields to complete here, but if I click on the advanced tab you see we do have some additional options. Now in the case of what we're looking to index here, we don't need OCR, so I can turn that off if I need it. If I need to. OCR is optical character recognition, and this is where things like videos and images are automatically scanned by DataBelt, and the text that appears with them is teased out and actually saved into the database as metadata so that we can search on it. In this case we're only interested in audio recordings, so I'm actually going to turn off the OCR aspect. Audio transcription is obviously something we need here. We want to automatically transcribe the audio files that we find, so I'm going to leave that ticked. Video parsing is not something we need for this use case either. We will use it on our later use cases though, when we compare our AI models against CCTV footage. So I'm just going to complete the information on the left here. So we have our indexer name, so this will be prison phone call analysis. We're going to choose our indexer. Our indexer is in effect the worker that's going to go off now and do this indexing. And we have to specify the path. So this is where our data is located that we want to index. So we click on create, and the process that we saw just a few moments ago, that visualization of that data crawler, where we had a number of the different workers going off and iteratively going through folder structures and indexing files. That process is now currently happening, and here is our index. You'll see its status on the left hand side is amber because it's not yet completed. And I can open up our index here, and this is going to tell us in real time the status of our index. It's currently queued, and it will very soon kick itself off. So the index has now started, and scrolling down within our index modal, you'll see some high-level statistics about it. So we saw that it took only a few seconds to complete. There was only one file in share. We've only got one audio file in this example, and it was successfully indexed. So the total files indexed equals 1, and 0 files were skipped. And we can see the total file size there of 2.9 megabytes. This bubble chart here shows us the different types of files that are within that index. We'll see this in our later use cases have a few more different coloured bubbles showing the different types of files that exist on that index. And we also have the monitoring chart just down below, again where we do skip files because possibly we've told DataBelt to skip .exe files or files over a certain size. These would appear here. So now that our index is created, we can now search upon it, and that's what we're going to do next. So in order to search, we're going to need a case because that process needs to be audited in terms of who's doing what searches and what results are being returned. So we've come back to our My View page, which if you remember is where we create our cases from. And in this case we're going to create a data deep search case. We're going to give it a name. We can also assign an SLA to this, so a service level agreement. So it could say that for this type of case it should take 3 hours, or it could take 3 days. Those SLAs can also be automatically assigned based on the case type. So for instance, where we have a freedom of information request, that may have more strict timelines and SLAs associated with it, and they can be automatically generated according to your needs. So I'm now going to create our case, and it will automatically assign it to me. And just clicking on the action button, we can now create our query. So here's our query builder screen. So if you remember so far, we've indexed our phone recordings so that we can now search upon them. The words that were uttered in those recordings have now been transcribed. And our query builder allows us to ask questions of that index. So what we're looking for in this case is any utterances of the word burner. So I'm just going to type in burner and hit enter. And you see we have various other options here. We can set a fuzziness level, for instance. This is particularly useful if you're searching for somebody's surname and possibly that they may spell that surname incorrectly. We'll come on to this later where we look at Maureen Miggins in one of our later use cases. Her name has 2 G's in it. If we're looking for a document that only has 1 G in because somebody spelled it incorrectly, then we can assign what's called a fuzziness level of 1 edit allowed or 2 edits allowed. And this just means that if it doesn't give us an exact match, it may still return that to us. On the right hand side, we specify where we want to search for that information. If we were doing information for a freedom of information request or for a data subject access request, for instance, we may very well search all data stores and their indexes, and we could click this checkbox here. What I'm going to do in this case is just select the specific index that we created as part of this. And if I hit run query, DataBelt is now going to try and find us the audio recordings where the word burner has been found. And here we have our results. At the top we have the query itself, and then below we have the actual results. So in this case we can see one file has been returned, we can see its path, we can see its type, so this is of type .wav, so it's an audio file. We have its file name, and we also have a score, so how closely have we matched with our keyword against this. And if we just click on action on the right hand side, we can download the original recording itself if we want to listen to it. We also have the automatic audio transcription that has been carried out, and we can see indeed somebody is talking about a burner phone. He's going to get that tomorrow, based on, of course, when this was actually recorded. And we'll also see a key name here. Mariana's family are asking questions, and this is going to be something that we're going to be searching on later to see the relevance of Mariana, and to see if this person who made the telephone call is involved in any criminal activity. And so in our example, we have now passed that intelligence back to the prison service, and we've advised that, based on all of the telephone information, the phone recordings that are being provided to us, we have found a particular recording that contains the keyword burner, and we also have a time frame. We understand that the prisoner is getting that burner phone tomorrow, based on, of course, when that was recorded. So we're going to pass that information back to the prison service, and what's going to happen is they're, of course, going to raid that cell, try and locate that burner phone. What's then going to happen in the meantime is they're then going to extract that information and again, pass it over to us. And the police, or actually the prison service themselves, if they had DataBelt installed, would now go ahead with the next part of the use case demonstration, which is to index the content of that mobile phone so that we can do searches on the data that's within it. We saw from the phone recording the mention of Mariana, and we're going to be searching on that keyword to see if anything comes up on that phone that points us towards suspicious activity. So the first thing we do, of course, we need to index that data. So it's been provided to us by the prison service, it's been saved on a local drive, and we're going to go back to our CMDB or configuration management database and index that data by creating a new index. So in this case, if we go to our advanced tab, we will keep OCR on here, optical character recognition, because in our example we actually are going to have some passports in there, some JPEGs, some photographs or photocopies of passports, and we want to be able to use OCR to extract the information that's on those passports to make it easier for us to search the information that's on that mobile phone. And we're going to keep the other things on as well in terms of audio transcription, but we won't need video parsing in this example. So we're going to give our index a name. Again, we're going to select the indexer that we need here, so our worker, and we're going to enter in our path. So this is where our mobile phone information has been saved. And we're going to create a new index now. So here's our index. You can see it's currently queued, and this will kick off very shortly. It'll provide us with a status bar to show how far through its index process it is, and in this case it will be very fast. And there we go, scan has completed. In this case it took around 3 seconds to complete. We had 7 total files that are in that share. All 7 were indexed with a total file size of almost 500 kilobytes. Scrolling down a little bit further, our bubble chart gives us an indication of the types of files that were found there. So we have a PDF, a couple of Word documents, a JPEG and a .text file, and then our Mondrian chart tells us the same information, and it's just confirming to us that nothing was skipped. So our index has been created, and that means we can now search on it. And if you remember from the phone call that we transcribed earlier, the word Mariana was mentioned, and maybe that's a good line of investigation. Who is Mariana? What's the relationship of that person to the person that made the telephone call, our prisoner? So we're going to go back to my view and create a new case. And again, it's still going to be a data deep search case here. And we're going to search for Mariana. The case is being created and automatically assigned to me, and I can now action the case. And just like before, we're going to enter our search term, Mariana. And of course I may have spelled this incorrectly. Perhaps she has two N's in her name, or it's just spelt differently. We can therefore change our fuzziness level here. I'm going to say one edit allowed. Again, we're going to come over to our right hand side of the query builder, and this is where we specify where within our data estate we want to search, which indexes we're interested in. Like I mentioned before, for a data subject access request and the like, you can search for everything. In this case, I'm just going to search in the index that we've just created. And I click on Run Query. Down the bottom, we're going to have our query created. And I'm going to click on Results. And there we go. We have a match. It is a .jpeg file. We can see the path, we can see the file name, and also our score. So how closely did we match with our keyword against this record here? If we click on Action, we can see the automatically transcribed information that was taken from that image. And this is how we were able to match against Mariana, as Mariana's name appears, of course, naturally, many times on her passport. We can also download the original. And so we've been able to locate Mariana's passport, and it is on the burner phone that was confiscated from our prisoner. And so what we've been able to do with DataBelt is firstly find a line of inquiry. So using the automatic audio transcription capability of DataBelt, find those prison phone recordings that have those suspicious keywords in this case burner. We've then been able to direct the prison guards to that cell at a particular date or time to then search it, to find that burner, and then actually provide us with some very strong intelligence based on the content of the telephone call, but also the content of the phone. We have this Mariana's passport on there. Perhaps our suspect is involved in people trafficking, and that would be another line of inquiry that we will now progress by looking into that individual further. Our second use case relates to a fictional county lines shooting investigation. The purpose is to identify the vehicle registration number of a vehicle of interest and to pinpoint the time of the shooting. The background is that a police investigator is working on a drive-by shooting linked to a county lines drugs gang. A witness saw a Peugeot 206 speeding away from the scene, but didn't see the vehicle registration number and was unsure on the exact time of the shooting. The use case steps are as follows. Local CCTV footage is obtained from various sources near the crime scene. An investigation case is set up in DataBelt. An AI model of car, including a number of categories, such as Peugeot 206, is created. The CCTV footage is then indexed, and a data deep search in DataBelt locates the vehicle of interest, and the vehicle registration number is acquired. Please note in our example, the vehicle registration number is blurred or redacted. Finally, a PNC check can then be carried out off-system to identify the owner of the vehicle. The evidence is as follows. The vehicle registration number of the vehicle of interest has now been acquired, and the time of the shooting can be pinpointed. The vehicle registration number can now be used to identify the owner. So to start our second use case, we need to obtain the CCTV footage from various sources near the crime scene. So we've now acquired that footage and it's been saved onto our local drive. Now, instead of going through and manually searching through hours and hours of CCTV footage to try and find where our vehicle of interest is, and if it does indeed appear within the CCTV footage, DataBelt allows us to completely bypass that manual process and do it automatically. And the way we do that is by creating artificial intelligence models of what we're looking for. So if I'm looking for a cat, I can create an artificial intelligence model of a cat. If I'm looking for a car, I can create an AI model of a car. And that's exactly what we're going to do here. So going into our CMDB and our configure Keras section, we have a number of different models that we've created so far. Everything ranging, just as examples, from government documents such as P45, passports, and different types of passports. In this case, we've got the difference between Spanish and Italian. Credit cards, whether that's Visa, MasterCard, or Amex. And DataBelt is able to tease out all these differences. So not only can it find a credit card, but a specific type of credit card. And what we have here to support our use case are AI models that have been created in support of searching for cars. And the first one we have here is to do with cars, with the categories of Peugeot 206, BMW 4 Series, and Citroen C4. We also have an AI model around car logos, because of course that is usually quite a defining feature of a car, is its badge. However, we need to use both here because it could be our car appears on our CCTV footage, but the badge isn't seen because it's a side-on view. So we've created both here in support of our analysis. And in terms of actually creating a model itself, it's very straightforward. If I just go over to the edit button on the right hand side here, we create our model, in this case cars. We create our different categories. So in this example, I've just created 3 different types of cars. And you can see actually the numbers of images needed to create this model is actually relatively small in the grand scheme of things. And the process by which this is done is there are a number of images that are available to us open source. You can go to Google, for instance, and search for images from there. And you'll find that the more you use DataBelt, the more you actually acquire these images to support the category and model creation, so that next time, of course, you do an investigation that involves searching for CCTV footage, you may actually already have this model and the relevant category available to you. And in terms of actually creating the categories itself and the supporting data, we can just click on the upload button on the right hand side, and this allows us to access or specify a zipped folder which contains the data we want to upload. So in this case, we have a zip here that contains images of Citroen C4 cars, and so we can therefore upload that into DataBelt. Once those uploads are done, DataBelt then trains the model. And just to show you what training actually is, if we open up our manage icon here, it goes through 2 broad processes. It goes through a bottlenecking cycle and then a fine-tuning cycle. And all this really is DataBelt actually understanding the images that we've uploaded to it. What is the shape of a Citroen car versus what is the shape of a Peugeot? What do cars look like in relation to all of the other background data that DataBelt understands about the world? And it goes through what are called different epochs, and these are just different training cycles. And you can see this accuracy column here just goes up and up and up as it trains itself. What it then does in the fine-tuning cycle is it actually tests the model itself against an image from within that model, or many images from within that model. So it'll take its model, it will set aside 1 or 2 or more images, and it will actually test and say, using this image, how accurate is it against the model that I've created? Is there a match? And so it will therefore go through that cycle until it's reached an accuracy level that it's comfortable with. Clicking on the statistics icon, we also get the same information but visually, and we can see we've actually achieved a total accuracy of almost 90%. So this is a relatively strong model that we have within DataBelt from only a very small number of images here of 192. It took around 20 minutes or so to train that model, and really all we're seeing here is kind of what we saw on the previous screen but visually, and we can see the training and the validation lines and how those increase over time with regards to the initial bottlenecking cycle and the later fine-tuning cycle. And the really good thing you can see here is that the training and the validation is all increasing as time goes on. So we've now trained successfully two models, one of cars, including a few different categories, including of course that all-important Peugeot 206 category, because from what our witness told us, that is the car of interest to us. And we've also got some logos here, the car badges that we've also trained. Our next step then is to index the CCTV footage that we've obtained. So we'll go back to our CMDB or Configuration Management Database. We go to the file share where we've saved our CCTV footage. And we can create a new index for that CCTV location. This is something that I've already completed, and this took around 3 seconds to index that data. And now that our index has been created, we can now ask questions of it and do searches against it. So I'm going to go into my view. We're going to create a new data deep search case. The case is assigned to me, and I'm now going to action the case. Now, you may remember from our previous example, we actually entered a search term at the top here in terms of burner and also Mariana. In this case, because we're using AI models, we actually come to our classification filters section. And if we expand that, we can see what Keras tags are available to us. And in this case, I'm interested in finding whether it has a match against the Peugeot logo. So I'm going to put that as should, and also the AI model of a Peugeot car. And just like before, we're now going to specify the area of the system that we're going to search. In this case, our CCTV index that we've already created. I'm now going to run the query, and because as part of the indexing process these AI tags are actually automatically analysed and attached, the query process is actually incredibly quick. We can now view the results of our query. And you'll see with our query at the top, we have found 3 files below, 3 different MP4 files that could be of interest to us. I'm going to open up one of them as an example. We can see the CCTV footage at the top, and we can play it. And importantly, especially if this was a larger video, if we come down here, we can see a timeline of all the different frames where DataBelt has found a tag. And in this case, we're particularly interested, of course, in the tags that relate to a Peugeot. Now, I'm just going to go to one of the later frames here. If I click on Go, it takes me to the actual frame within the CCTV footage at the top. You can see we have a Peugeot there. And if I click on Tag, this will show me as well the accuracy. So it's 76% accurate on finding a Peugeot. And actually, if we come down to the logo part as well, it does feel relatively confident that the Peugeot logo has been found, versus a BMW logo of 4% and a Citroen logo of 0.005%. So we've now been able to, imagine this was a particularly large CCTV recording. We've been able to pinpoint where we have got matches against our AI model, in this case, in these few frames at the end of our CCTV footage, and we can confirm the accuracy. I visually can look at this and recognize a Peugeot 206, and DataBelt is also confirming that. Now, in our example here, because this is stock footage, of course, the vehicle registration number has been redacted and blurred. However, the next stage of the process in real life, of course, would be to take that vehicle registration number, save that into our case, and do a search to see who is the owner of that vehicle to help progress our investigation. Our third use case, and the first relating to corporate data, surrounds custody suite photo weeding and a freedom of information request. The purpose is, in accordance with the principles of MOPI, to ensure that police forces are not unnecessarily keeping personal information on the public. The background is that a police force has received a freedom of information request, sponsored by a local MP, on personal photo data held by the police, in particular custody suite photographs. The police want to make sure it complies with MOPI principles and Part 3 of the Data Protection Act 2018. An HMICFRS is due next month for appeal assessment, and the inspector is keen on understanding data management status in readiness for a possible ICO code of practice. The use case steps are as follows. We start by creating a freedom of information case in DataBelt. We then create a regex or regular expression tag that can identify criminal record number matches within photographs. Next, the custody suite photographs are indexed to capture metadata such as the file's name, whether a CR or an ASN number exists within the photograph, create date, file type, etc. Next, we search for any photograph that meets the following policy/criteria as being a candidate for weeding. That is, it does not have a CR number and is older than 5 years. Finally, DataBelt then produces a report of those photographs which are candidates for weeding. The results are that the number of image files that should be retained can be reported in the Freedom of Information case and as contribution to the MORAL report. To start off our first corporate data use case, which is relating to custody suite photo weeding and a Freedom of Information request, we're going to start off by creating a case within DataBelt. And this can be used to store all the details about the Freedom of Information request that's come in, all of the conversations that we've had about it with the originator and other members of the police force. And you can see here we also have the ability to set an SLA or a service level agreement. This can be done automatically, of course, based on the case type that you select as well. And it allows us to track against the SLA, whether that be an internal SLA or something that's mandated by the regulator, for instance. And what we're looking at doing here is to weed out and delete or destroy the custody suite photos that we no longer need. And this has been prompted by a Freedom of Information request that has come in asking us, how many photographs do you store on members of the public? So what we're looking at doing here then is actually cleaning out and cleansing the ones that we don't need so that we can then respond to that Freedom of Information request with an accurate figure about those that we do need to keep going forwards and therefore give a more accurate response to the originator. So our first step there is to actually set up the case itself. That's going to be the thing that continues throughout this Freedom of Information request from start to finish. But there are a couple of prerequisites that we need to do before we actually start searching and deleting data and the like. The first is to set up what we call a regular expression. Now, if you remember from when I introduced this use case, we're going to be searching for photographs that don't have a CR number associated with them and that are older than 5 years. So what we're talking about is where we have a custody suite photograph and within it there's actually the text CR 12345, for instance. So what we want to be able to do is use DataBelt's OCR, or optical character recognition capability, to, in effect, look at all the photographs that we have and pull out those CR numbers and actually save them as plain text, so that we can therefore find those which do not have a CR number as part of our weeding process. And the first part that allows us to do that is to set up what's called a regular expression. So I'm going to go into our CMDB, our Configuration Management Database, and you'll remember we came to configure Keras in our previous use cases, and this is where we configured our artificial intelligence models. What we're going to do now is come to our configure regexes section to do a similar thing. Now, a regular expression is a way of identifying a certain type of data. To give you an example, if you think about all the postcodes that exist within England, they all follow a similar format. Not all postcodes are the same, of course. However, they all conform to the same format. The same thing goes for the examples we have on screen here. So when you look at the pattern that a Visa credit card number has, they're all different. However, they conform to this pattern that we have on screen here. And when it comes to a crime reference number, for instance, that's very easy for us to do. We've done a very simple example here, and we've just included literally C and R. And what we're saying is, you could expand this and also have the number of letters and numbers that come after it as part of the regular expression. But for this use case here, we just want to find photographs that do or do not have CR within them. So once we've configured our regular expression, we also need to bear in mind the fact that we want to find images that are older than 5 years. And we can do that with just DataBelt's standard indexing process when it looks at the metadata of those files. So we're now going to move on to the indexing process. So I'm just going to go back again to the CMDB and go back into our data store, and in effect this is where we've either moved the custody suite photos into a file share that DataBelt has access to, or better yet, we've simply pointed DataBelt at the place where those custody suite photos are actually saved. I've created an index already because we've already gone through that process a couple of times from the previous use cases. So I'm just going to load that up now, and it's this one here, the custody suite photos index. And I'll just open that up briefly just to give you an idea of the types of records that we found here. So this took 3 seconds to complete. There were 33 files in the share. 32 of them were indexed and 1 of them was skipped, and that could be anything from file types that we've decided that we don't want to index, or file sizes. So in this case, anything larger than 5 megabytes we have said please exclude. And then moving down to the bubble chart, you'll see the makeup of those files, predominantly JPEG files, but also a text file and a spreadsheet has made its way into that file store. So now that index has been done, we can now do a search. We're going to ask questions of that index. So I'm going to go to our case manager and move on to the next action, which is to actually carry out our search. You'll remember in our previous use cases, we entered search terms here. We also used our classification filters when it came to the Keras tags. In this case, I'm going to go to the regex tags section, expand that out, and I'm going to select the crime reference number regex, and I'm going to say it must not contain a crime reference number. And what this is going to do is allow us to find the images that do not have CR within them. We also have the additional filters that we need in terms of date range. So for instance, you'll see down here we have a created date, and we can go through and specify that what we're looking for needs to be older than 5 years, or whatever you decide in terms of a date range. Just like before, we then select the file share and the specific index that we're looking for. Again, we could select all data stores and their indexes, but just to keep it really nice and quick, I'm going to select specifically the index that we created as part of this process, which is this one here, and we're then going to run the query. The query is completed, and we can therefore view the results. And there you go. You can see we have a number of results here. We have 20 records that have met our criteria in that they don't contain a crime reference number and they are whatever age we specify. Let's load up one of the images to check. We can see a CR number has not been located in the image, otherwise it would have been using the optical character recognition technology, would have been transcribed within this preview box here. We can also download the original to check, load it up, and confirm that indeed we do not have a CR number against that custody suite photo. And then finally, I can actually share the query itself with whoever it needs to go to. So instead of actually exporting a CSV and then actually sharing it with the IT team that way, I can actually just go ahead here and share that with my colleague. When my colleague loads that up, they will literally see exactly the same details that we're seeing here, and they can go ahead and carry out whatever deletion they need. In terms of then complying with the Freedom of Information request, go back to our case. We can then add a note in relation to our search. So for instance, 20 records have been identified for deletion. Once my colleague has then deleted those records, again, as I said, I can rerun the search just to confirm indeed they have been deleted, and I can actually also reply to the originator of the Freedom of Information request to confirm now that we have 20 fewer records than we did before. Our final use case, and the second relating to corporate data, surrounds DSARs, or Data Subject Access Requests, and disclosure for a legal HR case. The purpose is to execute a data subject access request, then provide the collated information for legal disclosure. The background is that a member of civilian staff, Maureen Miggins, has claimed unfair dismissal and as part of ongoing legal discussions has put in a DSAR to her police employer. Part 2 of the Data Protection Act 2018 will apply. The results of the DSAR to be shared with the police HR legal advisor and the member of staff's lawyer. The use case steps are as follows. Step 1. Set up a DSAR case and related SLA. Step 2. Index the data estate. Step 3. We can then execute a search to locate key references to the originator and return the results with path locations. Next, some emails reference other parties as well as Maureen Miggins, so require redaction. And finally, data is then kept in legal hold in quarantine and disclosed in accordance with EDRM, or the e-discovery reference model. The results are that data relating to the originator can be located, redacted, and shared quickly and accurately with legal counsel. So for our final use case, one of the first steps of course could be creating our DSAR case here within our data classification and GDPR collection, but I've actually already gone ahead and created our DSAR case with its assigned SLA, and you'll be able to see it right at the top of this list once it loads. And I have already created an index, but I'll just show it you briefly. And it's this data index here, and if we have a look at it you can get a feel for what we have here. So it took around 3 seconds to complete. 69 files in the share. One of them was skipped, and that is likely due to its size. We specified a 5 megabytes limit when it came to creating this index. And here we are. Our bubble chart is now showing us a lot of different bubbles in the form of the different types of records and files that exist within that file share. Predominantly we have Word documents, but we have PDF, we have a couple of images, a spreadsheet, a PNG, just as examples. So now that our index has run, we can therefore go ahead now and actually progress our case. So the purpose of the case then is to conform to that DSAR request. So we're going to find all the information that we have on Maureen and then share that with her legal counsel as part of the case that she's raised against us. So let's click on the action button next to our case here. And in terms of searching, I'm going to keep it very simple. I'm just going to search for Maureen's surname, which is Miggins. And I am going to apply a fuzziness level here. So we're going to allow one edit. And this is really just where it's likely, of course, that somebody may have misspelt Maureen's surname incorrectly and just used 1G instead of 2. We would like to have oversight of the references to a Miggins with 1G, even if it may relate to another person. We want the opportunity to review that information in case it actually relates to Maureen Miggins. And of course I can enter in any of the search terms I want here. These could be national insurance numbers, her employee or police number, etc. Can all go into this advanced search query here. On the right hand side, I'm going to go ahead and select the relevant index. As I've mentioned a few times before, we can actually click this checkbox here to select all data stores and their indexes. However, for this one here, I'm actually going to select the specific HR data index that we created a little earlier on. We can then run the query. Query is completed. We can therefore view our results. And there we go. We have our query at the top, and then we have a number of documents, 57 in total, that we have found a match against. So my task now is to go through and actually validate a few different things. The first thing is that everything that is listed here relating to the Maureen Miggins that I've searched for. So I can do that by going through, clicking on the gavel button on each of these and actually reviewing the data that the DataBelt is showing to me. I can also download the original because I don't want to be sharing information about another Maureen Miggins, of course. The second part is, have we captured everything that's to do with Maureen Miggins? It could be that although every single one of the 57 files that we have here is to do with Maureen Miggins, there may be another 2 files that we've missed because, again, perhaps somebody has spelt Maureen's name incorrectly or whatever the reason might be. So it's a case of fine-tuning our query. Now, just as an example, in this document that we found here, this is a Word document, and it's got listed here the data that's contained within that document. And what we've got here is a disciplinary report saying that Maureen has been accused of shouting at a colleague and using derogatory language. The colleague in question is Matt Smith, and it could well be for the purposes of sharing this data. I don't want Matt's information to be shared. So I can just go ahead and redact his name and click Save. And just to be clear on that, that doesn't go back to the source document. Of course, that source document we still need to contain all of the information. It's important that we understand that it was Matt that she was accused of shouting at. However, what we have here within our index is a virtualized data lake. It's almost like a copy. It just turns out it's a copy that takes up a lot less space on a hard drive than the original source data. So what we're doing is actually redacting the virtualized data lake data, because that is what we're searching on and that's what we're sharing with our legal counsel here. So just to confirm, not editing the source data, this is simply updating our virtualized data lake data. And so I would go through and I would check all of these documents here, make sure they've captured everything that I need about Maureen. I can go ahead and fine tune that query if I need to. I can go through, do my redactions as necessary, and then I can go ahead and get these shared through our secure sharing portal. And what this does is it shares this link that you can see at the bottom with that user, and when they click on that link it will actually log them into DataBelt, and they will be presented with literally just the query results that you see here, so they can go through and have a look at the data that's been found. They can download originals if they have access to do so as well. So once that information has been shared, I will update my case. If Maureen or legal counsel has confirmed that the data that we've shared fulfills the requirements of the data subject access request, then we would simply go and close our case down. So to recap, DataBelt isn't just a data governance tool. Its advanced features work to address the real-life requirements of modern police and law enforcement agencies in both the investigative and corporate data contexts. DataBelt provides access to data forensics never thought possible before through the creation of its virtualized data lake. It puts sophisticated machine learning technology in the hands of non-data scientists while supporting all aspects of police corporate data management. DataBelt provides a middleware bus and data supervisor for bringing together datasets from different locations, systems, and formats to assist with criminal cases and corporate data activities. It allows all aspects of data-led policing work to be managed effectively, efficiently, and quickly. Finally, DataBelt eradicates human and data errors, slashes time, effort, and costs. Thank you for watching. Please get in touch if you'd like to arrange a demonstration tailored to your specific use cases and needs.